All right, so we're back at it again with some LeetCode. Let me make sure all my settings are good here. All right, so yesterday I was doing a stream and I had to leave, so I wasn't able to actually finish it all the way. So I want to start today where not where we left off, because unfortunately, like I did some questions yesterday that I'm gonna have to do again today, just to make up for the lost time yesterday. So we're gonna start again from that moment. Let's see what we can do. So I think yesterday. Yeah, I think we started off on this one yesterday. I was like really going at it and I got stuck for like a really dumb reason, but I've had some time to think about it and now I was able to come up with a good answer. So let's look at this one again and let's think about it. So how many numbers are smaller than the current number? By the way, for anyone new that's watching, this stream isn't so much for me to teach you how to leak code. It's more of you hearing my thoughts and hopefully getting on your own sort of journey for LeetCode. My intent with this stream is to do all the questions on LeetCode. So if you're watching and if you're looking to start your own LeetCode habit to try and get into that next job or try to just sharpen your skills and hear someone else going through them, then I would love for you to join in. I'm starting off today with 1365. How many numbers are smaller than the current number? I'll go ahead and post the link in the chat and let's just go from here, right? So welcome everyone and let's go for it. So how many numbers are smaller than the current one? So yesterday I was sort of going back and forth with sorting this and sort of coming up from like increasing order. So let's copy this one, right? And now let's see what does this look like now when we sort. Really what we need to do here is we need to keep a map of the indices of each one of these different ones. At least this is like the first way that I would try to do this. Maybe with the upper bounds, we can create an array of like 500 indices, but I'm okay with creating my own sort of object literal to represent the indices of where they are. So like, if you think about it, like for 1, it's at position 0, so there's 0 numbers less than it. 2 is at position 1, so there's 1 number less than it. 3, right, is at position 3, so it's 3 numbers less, and 8, there's 4. Now, like, the issue is when you have duplicate numbers, like we wouldn't say 2 has 2 numbers less than it because there's already a 2 that we accounted for earlier. So really what we need to do is we get the index only if it doesn't already exist, right? So like we get to 1 doesn't exist in our map, so we put it in here. We go to 2 doesn't exist in our map. I'm having some trouble aligning here, so 2. Now when we get to the next 2, we see it already exists, so we don't do anything with it. So that would be how I would like start creating this sort of thing. So let's go through this and see what we can do. All right, so the first thing I want to do, like I showed here, is I want to sort this in increasing order, and I'll do that using JavaScript's sort function. So I'll say sorted nums. I'm going to create a copy of my nums. That way I don't, this is sort of like a pure function. I don't alter the input parameter here. I'll use sort, pass in my callback, and I'll say a minus b. So now we have our sorted nums. And now what I want to do is create, I guess we can create like an index map. And what we want to do here is for let I equals 0, I less than sorted nums length I plus plus. We're going to go through this and just update it if it's not already there. So if, let's say, if index map at nums of I equals undefined, right? So nums of I is going to give us that 1 in the sorted array. If we see index map index map at 1 is undefined, then we can go ahead and set the index here. So index map of nums at I is equal to I. Let me go ahead and print this out and see what we're dealing with here. See what we have so far. 0, 1, 2, 3 is 4, 8 is 0. Let's see, so it still looks like we counted this twice. Oh, am I not going through? Yeah. So I actually this should be sorted nums in here. 1, 0, 2 is 1, 3 is 3, and 8 is 4. And if you look at the output, that's essentially what it is, right? So now we have an array now. We have a map that maps each one of these, right? So we know 8, we're going to look up 8, we're going to get 4, 1 is going to be 0, 2 is 1. So really what we can do now is we can map over the nums and just return, like we can now return a new array that represents these indices using our index map. And I think that will be good for us. So we can do return nums.map. And here we get the num. And here, what is it that we want to return? We want to return index map at num. And that should give us index map at num is 8, and that should give us 4, right, from what we saw earlier. Let's see what this gives us. 40113. And over here we have, let's do the other test cases to make sure we're doing all right. 21030000. Okay, 88.17. So I'm like pretty happy with this. And now one thing I really need, I keep telling myself that I'm gonna do this like every stream, but I haven't been too good with it. So I'm gonna really try now is I want to really try and go through the time and space complexity. By the way, I see we have like, it seems like we have a lot of watchers right now, so I really appreciate everyone being here right now. If you have any questions, comments, you want to suggest a problem, or if you want to like critique my code, I'm very open to like criticisms. Personally, I think it's the only way I can grow. So yeah, feel free to drop something in the chat. And if you're worried that you're gonna like lose out on the stream, I upload these to my YouTube channel afterwards, so they'll be available once the stream is over, and you can look at it later to like go through the own questions yourself. So let's like look at this and see what's happening. So let's start off with this sort right here, right? We know that at least in JavaScript, like if we're on, let's say we're on Chrome, we're using Chrome's V8 engine, sort is normally going to use like a quick sort. So for all intents and purposes, we can say the time complexity of this is going to be n log n. And then for our index map, let's say this is just like time. For here, this is going to be linear. Right, we're going through all the sorted nums. This is going to be like an on time, and here we're doing another sort of linear traversal of our input array here. So really it's like on log n plus n plus n, so on log n plus 2n. N log n is the thing that wins here, so really the time complexity here is like the bottleneck is the sorting here. And then for space complexity, like I wonder, I'm always like confused because when I see people use like object literals, they say, oh, the time complexity is n, it's not fixed. And I guess, yeah, I guess it depends on the size of nums, how big this will grow. Maybe we could do better and use like a fixed size array. Since we know our upper bound is going to be 500. I wonder what we can do. This is going from 0, nums at each nums at I, but nums.length will be 2 to 500. So could we do that? Like if I were to create an array of size 500, could that help? Perhaps it could. I won't really go into details of that. So again, like this stream is not really to teach so much as it is as me just going over my own thoughts. And the point is like for you to also open up LeetCode and just go through it. Think of this like a coding podcast where you can just listen and do questions along. So I'm pretty happy with this. Let's see what the discussion has to say. So hash map solution with explanation. Looks like here some people are doing this in linear time, but we're doing sorting and counting. Can we do counting sort? Let's see. Is that in a bucket? So store the count in a bucket and take the running sum. The running sum of each one of the counts. Always learn more stuff by going through the discussions. So store the count in a bucket and take the running sum. We create a new array of count of 101. New res of nums length. Count of nums I plus plus. And then count of I plus count of, okay, interesting. Count of I plus or equals count I minus 1. If nums I equals 0, res of I equals 0, else res of I equals count of nums I minus 1. I like really want to see, I like to do this in person. Store the count in the bucket and take the running sum. Yeah, here it's just linear time. It'd be fun to implement this. Like I can't, like I sort of understand what they're doing. I'd be lying if I said that I can just look at this and immediately understand. So again, I would encourage everyone to probably, I'm gonna like actually put this in my own notes. That way I can revisit it later because I do want to go over that solution myself. Cool, so let's get to the next one. Like I said, yesterday I had to end the stream part way. So I already did some of the questions, but I just want to do them again so that we're in line with everything that we've done. So let's get through here, get this next one. Right, so how many numbers are smaller? Yeah, number of steps to reduce. Yeah, I'm gonna like refresh this so we have a clean slate. It says given an integer num, return the number of steps to reduce it to 0. In one step, if the current number is even, you have to divide it by 2. Otherwise, you have to subtract 1 from it. So the first thing I think of is just like straight up simulation. And I already know from looking at this question before that you can do something really clever that actually doesn't improve the time and space complexity, but it's just one of those clever things to know. It's like very uh, bitwise manipulation heavy. There's like this book that I remember reading. It's called like, well, I didn't read. I just know that it exists. It's like Hackers. Oh, is it Hacker's Delight? Hacker's Delight, yeah. So if anyone's like interested in learning more about bitwise manipulation, I've always heard this book is very good and it'll teach you how to do like common operations using bitwise manipulation. So like absolutely something that you can use to impress an interviewer and probably good for your own knowledge. In practice, like I've been a software engineer for 5 years, and in practice, I haven't ever used bitwise manipulation practically. But it might also be the domain I'm in. I do a lot of front end development, and maybe it's not as important there as maybe something in like game development. But anyway, I'll put the name of this book in the chat just so people remember. So Hackers Delight, in case anyone is interested in learning more about bitwise manipulation. And I spelled manipulation wrong, but I think you all get the deal. So for this one, we'll just do a simulation. So give it an integer num, return the number of steps to reduce it to 0. So let's say the amount of steps is 0, while num is not equal to 0. What are we going to do? With one step, if the current number is even, you have to divide it by 2. So if num is even, oh, it's even, then we can just apply num equals math.floor, num divided by 2. Using math.floor in JavaScript because it doesn't do like truncation like you might get in a language like Java or C Sharp. You have to round it down to get the whole number. So else num equals num minus 1. And then at each step, we will increment steps. Let's see what this gives us. Return steps 6 and 6, 6, 4, 12, 6, 4, 12. Cool. Pretty happy with this. I don't think there's like if you look at the discussion, simulation is a way of solving it somewhere, or maybe that's like the solution itself. It says here like, yeah, simulation, the easiest, the most intuitive one. I am like I'm comfortable in saying, see, it says here that the time complexity doesn't change. Like if you know this, like if you know how to solve this well with bitwise manipulation, then for sure, like use it to your advantage. Um, By the way, I see that I have some new followers on Reddit, so really, like, truly appreciate that. That's super awesome. I'm glad that people are benefiting from this. I enjoy doing this, and I'm trying to get better at it. So I think it's really cool that people are also seeing it. And like, I don't want to like, I'm gonna spend a quick 2 seconds on this, but at the end of the stream, I will put a link to this YouTube where I have my previous streams. So in case anyone wants to start from ground zero, like right from the beginning, you can watch these streams and follow along with me to get to this journey of doing all 582 easies and then all the mediums and all the hards. That's like my plan. I'll link to it again later, but again, really appreciate everyone watching. So yeah, I was saying about this one, like if you know how to do this, it's really cool. But readability is very important in practical software. Like I have read code that's very hard to read, and it might seem very elegant, but I've also read code that's very easy to read and it's just as elegant, and I always prefer the one that's easier to read. This is something that a new developer can walk into and understand. You know, if you start doing something like this, I mean, maybe I'm like overcomplicating it. Maybe it's not that bad, but you know, like lean to the thing that's more readable. It's not like I don't think like the code, like the elegant code or really beautiful bit manipulation code you're writing. that's really for you, right? Like the computer doesn't care, but like the code is really important for you and future you and other developers. So just write clean code that's readable. Anyway, my 2 cents. All right, so goal parser interpretation. I like that cat that comes up every time. He's gonna be like my little mascot. Yeah, I want to give a shout out to this person here. Shout out to Jithu or Jacob for recommending the plugin. So yeah, Jithu had an issue with like the background being white, which admittedly it is probably a little bit annoying. So found this really awesome extension. I think it's called LeetCode Night, and it just makes the problem space in dark mode. And that's why every single time we open a new question, you see that cat on the bottom right. I think it's pretty cool, pretty funny. Okay, so goal parser interpretation. Okay, you want a goal parser that can interpret a string command. The command consists of an alphabet G, open parentheses, or parentheses with AL in some order. The goal parser will interpret G as a string and the string O. Okay, so we're just going to parse this command and turn it into this. Now, like, one good thing to think about is, like with strings, leading and trailing spaces, can we always, like, is each token always going to be valid? Is there a case that, like, this parentheses will have some other character in it or other characters in it that are not A and L? I think it says that, yeah, command consists of G. So like this is very important, right? This is something that you should ask your interviewer, and you should confirm with them that the string is going to be valid. Because if not, you might miss out on some edge cases. So because of this, we can write code that's, it's going to make some assumptions, but we've already clarified this with our interviewer. So I think it's okay. So let's see. We're going to create an array here, interpreted, and now we're going to start going through our command. So for let I equals 0, let me just minimize this a little bit. I less than command dot length. Now I'm going to leave off the update of the for loop because I'm going to do my own manual update. And I guess you could do a while loop if you wanted, but I'll just do the for loop here because I like that I get to set the variable from within the body here. Not really the body, but the parameters, I suppose. So let's keep going. So I want to get my command. Command equals, no, let's say const current command equals command at I, right? Yeah, cool. So we have a couple different edge cases. So if current command is equal to G, then we can do interpreted dot push current command, right? And then in this case, we're just going to increment by 1. Else if the current command is equal to an open parentheses, now we have two different cases. So if current command is equal to open parentheses, see, and I wish there was like a better way. If current command is equal to open parentheses, if now the command at I plus 1 is equal to a close parentheses, what do? We want to push in O. And if it's like, so we're at this G here, if we get to I and it's an open parentheses and the next one is a closed parentheses, I is now going to have to be incremented by 2 to get to the next open parentheses or the next token, I guess you can call it. I plus it equals 2. Else if, let's see, yeah, else if command I plus 1 equals A, then we can sort of like copy this again. Well, not sort of, we will copy this again, and we will push AL, and we will increment this by 4, right? It's like it becomes very clear like here. If we're at I here, we go 1, 2, 3, 4 to get to the next one. And then at the end, we'll have an array that has all the different tokens, so we can return interpreted.join. Let's see what this gives us here. Goal, algalug. It's a nice word. 58.78. Okay, so let's think about our time complexity again here. So we have interpreted, well, let's think about time first, right? We're iterating through the entire string, and even though we're not hitting like every single command or like token, we're still having to iterate over the whole thing. So it's a linear time complexity. That's what I would label it as. And then this interpreted, I mean, interpreted is not going to be the size of interpreted is not going to be the size of the input, right? Unless if the input's like all G's, then I suppose it could be, but like it's going to be the size of like the different tokens that we get, which I guess again, if like all this was G, then it really would just be trending toward the size of the input command. So I think it should be like O of n, I would say linear space complexity and linear time complexity for this one here. So let's keep moving to the next one. So decode XORed array. This one's like very interesting. It's kind of cool. This one's straight up like properties of XOR. There's like a good video. There's like a lot of videos you can watch on YouTube for that. But really like one of the things that XOR helps you figure out is like a third piece of information. If you have two pieces of information, you can figure out a third piece of information using XOR. And that's really what it is here, right? Like we have our first piece of information is encoded, our second piece is first. So then to figure out the next thing here, we have all the information we need and we already have first. So here, if I do like decoded equals an array, decoded is going to be the thing that I return. I know that I have first in there already. So for let I equals 0, I less than encoded dot length I plus plus, I can say that decoded dot push is equal to the current encoded at I XOR of the decoded dot length minus 1. And that should give us the answer 1021, right? Because like we already have like our output first. So now like this first one plus or XOR this one gives us 0, right? And then 2 and 0 gives us 2, and then 3 and 2 gives us 1. That's how we get to there. So it's just one of those things that like you just need to know, unfortunately. But hopefully now you do because you were exposed to it on this question. And if you ever get to like some case like this where, oh, I need to get some like other piece of information if I have two and I'm missing like one, perhaps like an XOR could be useful. Just something I want to throw out there. So that's pretty cool. All right, nice. Let's keep going here. Decompressed run length encoded list. Say hello to our cat down there. All right, so we're given a list nums of integers representing a list compressed with run length encoding. Consider each adjacent pair of elements. Nums 2 times I with I greater than or equal to 0. Concatenate all the sublists from left to right. So I think they give us frequency of 1, value of 2. Yeah, so they give us a frequency, and this is the value, frequency and value. So we have 1, 2, and then we have 3 4s. Okay, so let's do const decompress. We can now go through, I'm going to let, because like, no, let's do I less than nums dot length, I plus or equals 2. Really what I want to do here now is say like while nums at I is greater than 0, I can do decompressed dot push nums at I plus 1 and then nums at I minus equal 1, return decompressed 2444. Okay, so what do we do here? We have this like index I that's only going over each one of these. It's incrementing by 2 every time because the thing that we're mainly concerned with is the frequency. We can always get the value next to it. So we start off with 1 and we say, okay, for 1, I want to push the thing to the right while the frequency is greater than 0, and then we decrement that frequency, and then we go increment by 2 to get to the next one, right? Nums I, which is 3, is greater than 0. Yep, so we push the next one 4. Now we decrement this to 2. greater than 0, yep, push to 4, decrement to 1, greater than 0, yep, push to 4, decrement to 0, greater than 0, no, break. And then we're at the end of our algorithm there. So yeah, I'm pretty happy with this. Let me just close some of these off. Super super happy with the people that are following me. I'm just getting notifications on my phone, and that's super awesome. Really appreciate the feedback here. This is like the sort of thing that motivates me to want to continue, even though I really do enjoy this, but it definitely helps. Again, like just for everyone watching, if you've missed out on the previous streams, if you're looking for a way to start your journey and you want to see some of these previous streams, I should let you know that these streams already exist on my channel here. Like I have two that I created yesterday to kick things off. You can watch this stream, you can follow me from problem zero all the way to where we are today. And it's cool because then we'll both be in progress, right? Like if you have followed me from the beginning, we have done roughly, and I say roughly because I think there's one more that we have to do to catch up. We've done roughly 24 questions. So think about it. If you are coming from having done no LeetCode, you can just watch these videos and now you've done 24 questions just like that. So yeah, if you want to like follow along, got the YouTube here. Like I'll put a link to the channel here. Again, like I'm really just trying to help people because I know for me it was impossible to try to start my own LeetCode habit. So I want to try and help people to do the same. This isn't a channel like NeetCode or Nick White or Kevin, I forget what his last name is. It's not so much of me teaching you LeetCode, it's just me. That's why I call it the accountability stream. Accountability stream because if you watch it, you'll be held accountable for your own progress. So with that, let's go ahead and continue through here. So did I just lose my, okay, no, I didn't. Decode, go parser, decompress. Okay, shuffle string. That's where we ended yesterday, I believe. Okay. Yeah, this one was interesting because there's like a couple of different ways to do this. Okay, there's two ways that I want to talk about, and then we'll get to there. So let's do like the first one that I think is pretty, it's sort of obvious, right? So we're given this string code lead, and we're given indices 4, 5, 6, 7, 7, 0, 2, 1, 3. So it means like for the first thing in 0, we want to look at the indice 4, and we want to place that in our output, right? We go to 0, O, D, E, look at the respective location in the indices, and put it in the output. So let's see how we can do that, right? Let's say we have const restored string. I should set this equal to be a new array that has size of s.length. This is just using like the JavaScript array constructor. So you can pass in a number here to dictate the length. Now, since I'm not using this thing like fill 0, it's just going to create an empty slot. Now, I would encourage like anyone who's like into JavaScript, it's very different to use. Let me see where it says it here. Yeah. Note, this implies an array of array length empty slots, not slots with actual undefined values. So an empty slot is not the same as having an undefined value in the slot. So that's what something like this creates for us. Creates an array that has s.length empty slots. So let's see what we want to do now. Let's go through s for let I equals 0, I less than s.length, I plus plus. I want to get my index, const index equals indices at I, right? Because now indices at 0 is going to be 4. And I want the restored string at index to equal s at the current I. Here we can do restored string dot join, and we can get that output string. LeetCode, LeetCode. So if I do this twice, ABC, ABC. Okay, so this passes, and like it's like a pretty good time complexity. Let's run it at 48, 90. So I'm like pretty happy with the time that we're getting here. And if we think about the time complexity, we're creating this new string, creating this new array that's going to be size of s.length. And iterating over our entire indices. So it's linear time, linear both with time and space. Now, there's this other method that you can do it. It's called a cyclic sort. And I want to look this up, like cyclic, or let's just do cyclic sort. Cyclic sort. Let's like see, let's see why it works. Like I just want to, or actually, I think there's this thing called like hacker rank 14 patterns or something. Yeah, because in here it talks about cyclic sort. So I just want to read this real quick and see if it like helps at all. So this pattern describes an interesting approach to deal with problems involving arrays containing numbers in a given range. So do we get that? I mean, we do have numbers in a given range. Okay, 1 through n, all values and indices are unique. The cyclic sort pattern iterates over the array one number at a time, and if the current number you are iterating is not at the current index, you swap it with the number at its correct index. You could try placing the number in its correct index, but this will produce a complexity of O n squared, which is not optimal, hence the cyclic sort pattern. So how do I identify this pattern? They will be problems involving a sorted array with numbers in a given range. If the problem asks you to find the missing duplicate smallest number in a sorted rotated array. This is interesting because actually these don't even have anything to do with the shuffle string. But like it works out though. And maybe cyclic sort is not even the right algorithm, but let's like run through an example ourselves and figure it out. So these are the indices that we have. And then let's get our string over here and let's just put this right on top and space it out a little bit better. Okay, so let's put our I here at 0. So what do we have to do? We not only have to swap indices, but we also have to swap the characters themselves, right? So we look at I. I is currently 0, and we see that this 4 is not equal to 0. So we're going to do a swap from index 4, and we're going to just swap these numbers, right? So the 4 becomes a 0, and the 0 becomes a 4. Similarly, we do the same thing with the characters. This becomes an L, and this becomes a C. Like just right now, this was like a correct swap because we know that the C will actually be there in the resultant string, I guess. We know that L will be there, and we know that this should be 0. So now let's increment I by 1. Now we're here at I equals 1. Excuse me. We have a 5, so we know that's not right. So let's do the same thing. We're going to look for index 5 now. So 0, 1, 2, 3, 4, 5. Right? Yeah. 0, 1, 2, 3, 4, 5. We're going to do the swap here. So 2 and 5. Now we're going to switch. We're going to put the O here and the E here, right? So these are both correct, but the index itself is not. This should be 1, but it's 2. So now we're going to do the same thing again. We're going to swap the thing in the second position. So this becomes a 6. This becomes a 2. This becomes a D. This becomes a E. Again, this is not right. This is now a 6. So we go to the sixth thing, which is the 1, right? 1, 2, 3, 4, 5. Wait, 0, 1, 2, 3, 4, 5, 6. The 1. So we swap, put the 1 here, put the 6 there. Now we take the D from over there and put an E here now. And now look at this. Now we're back to where we like finished. Oh, nice. Someone put a link here. Probably it's going to be like, is it a link to, wait, how do I, it's being hard to copy. Oh, is this not code leet? Wait, I do want to copy this. Hopefully it's a Avicii. Nice. Summer vibes. That's cool. Well, I'm glad that it's music and not like something else. That could have been anything else. That could have been anything. But I'm glad that it was this. It's good music. Good people. It's hard to see the entire screen. Please zoom out. Thanks. This is oh, because I'm guessing yeah, good. That's a good point because I guess this is meant for like desktop viewers and not mobile viewers. Yeah, because I tried watching the stream myself on the phone and it doesn't look very nice. But like if you like once I'm done with this, I don't know if you missed it, but I will upload this to my YouTube channel and from there it's gonna be a lot easier to view. Hopefully hopefully that's all right. I don't know if I'll change it for now just because I'm like sort of new with OBS and like the streaming, so I don't want to mess anything up. But I'm gonna I'm gonna comment or not gonna comment. I'm gonna copy this note you left. And that way, after this stream is done, I can do some experimentation of my own and see if I can get a nice resolution for mobile phone viewers, if that's what you're looking at. So apologies again. I don't want to change it midstream just in case anything like goes wrong. But thanks for letting me know. Yeah, no problem. Yeah, again, like I really wish I could change it for you, but don't want anything to mess up. But keep like keep a lookout for the next stream because the next stream might have it better. And yeah, okay, cool. So let's see what we can do here. Like using this method, let's see what we can come up with, right? So essentially, what are we doing here? I know I'm going over all the indices. That's like, it seems like a good place for me to start. Now, I can't change, like JavaScript strings are immutable. So I want to create a copy. Let's do like scopy equals s. So we can create a copy of our string here. And now let's see what we can do. Like for let I equals 0, I less than indices dot length I plus plus. I'm going to remove my previous solution and let's see what we did. So the first thing we did, like we kept doing these swaps while let's see, while I, which is 0, is not equal to indices at I, right? Because what did we start with? We started with 4. So while 0 is not equal to indices at 0, which is 4, we can do these swaps, right? And this is not what I want to do. I don't want to. Does this actually? Let me see something. Console.log. I forget. Will this create will that create the array for me already? Oh, it really takes long just for me to see. Oh, is this? Yeah, it's gonna time out because I have this right here. Let me comment that out. Okay, that's fine. Code lead. Where's ABC coming from? What? Oh, ABC is just the next string. Okay, that's copy. So what do we want to do in here? Like I know I definitely want to swap. I definitely want to swap code lead and indices. So I'm gonna kind of do it in like a, let's do temp car equals s copy at I, and then s copy at I, we want to make it equal to, like s copy at 0 should be equal to s copy at indices at I, and then s copy of indices at I equals temp, right? Let's just like go over this and make sure that at least this swap is correct. So temp car, so car just for characters, s copy at I, s copy at 0 is c. So we have temp car is equal to c. And now s copy at 0, which is here, is equal to, let's see, indices at 0 is 4. So S at 4, 0, 1, 2, 3, 4, L. Okay, cool. And then S copy at 4 is equal to temp, which is C. So that should give us that swap right there. And now let's do const temp index equals, we can do indices at I, right? That's gonna be 4. I want to make indices at I be equal to indices at I, right? I think that should work. Indices at 0 should be equal to um, indices at 0 is 4. Indices at 4 is 0. Okay. And then the indices at 4 should be equal to temp index. Does it run Pascal? LeetCode? Does it run Pascal? I don't know. Wait, is that? Is, oh my God. Wait, is that a language or that's funny. I don't even Pascal Pro. Okay, I forgot if like Pascal was a language. I was thinking of like Camel Case and Pascal Case, but no, looks like it doesn't, unfortunately. But who knows? Maybe they're gonna come up with it like soon. Okay, so will this work? I mean, let's just go for it and see what happens. Because then at the end, scopy at I. So can we just return scopy.join? What does this do? Temp index, temp car. It looks like it's gonna time out. Time limit exceeded. While I is not equal to indices I, temp index. I always feel like it's something with this one because I was sort of doing this yesterday and it was also messing up in like this swap right here. Const temp index is indices at I. Indices at 0 is 4. And then indices at, although is, let's think about this, the temp index is 4. That's just the thing that I want to put it in. Indices at 0 is equal to indices at indices, right? So this becomes a 0. And then indices, oh, but we lose that information from here because I'm like overwriting this before I ever, should I copy, should I maybe, this might just be like the same thing the other way, but let me see. What if I copy the 0 first? Say indices, so indices at 0 is 4, indices at 4 is 0. Now indices at 0, should that be, see, I need to, oh, I can also say indices, that's 0, haven't changed anything yet. If I change indices at indices I equals indices at I, then indices at I equals temp index. I think I have to like, let me go over this again. Why is this like such a weird swap here? Is it because we're dealing with like nested arrays? Const temp index, indices. Okay, let's go over this again. So I is 0. So indices at 0 is 4. Indices at 4 is 0. Okay, that's like my temp index. That's really the value I want to set, not so much the index. Indices at, let's actually go through all this like this. Be way better if we actually write this down. Okay, temp index equals 0. Indices, so indices at 0 is 4. Indices at 0, 1, 2, 3, 4 is now equal to the thing at indices 0, so that's 4. And then indices at 0 equals temp index, which is 0. Don't want to do the insert here. 0, 4. Now we come back while 0 is not equal to indices at I, which is still 0. Okay, that's fine. Let's go for this again. Oh, nice. So that was like a weird swap because this doesn't follow, well, let's see if we get the answer. 54.23. So I'm not even sure if it actually, I mean, the space complexity, we didn't, I guess I still have to create a new array here. But this is just, I guess, like, this is a different way of thinking of the same problem. I think it's very cool. I'm going to share this link with all you guys because this also brings up some like pretty cool, like other pretty cool patterns that you can use yourself. Cool. So let's go back. Let's keep going. Let's see where we are at right now. 24. 24 questions. Cool. So if you've made it this far, you've done 24 questions. We have a very long way till 582, but hey, we're having fun. I'm having fun. Hope you guys are having fun. So let's go from here. All right. So doing 2194 cells in range on an Excel sheet. All right. So a cell of an Excel sheet is represented as a string, column, row, where column denotes the column number C of the cell. You're given a string S in the format call row column. Wait, what? Rows, then row number R of the cell. The rth row is represented by the integer R. You're given a string S in the format of column row, column 2. Row 2, or column 1 represents the column C1, row 1. Return the list of cells such that R1, row 1 is less than or equal to X. Column 1 is such represented as strings. So K1 to L2, K1, K2, L2, L1, A1 to F1. But we could be given, wait, are you given a string in the format call row? Oh, okay, column K row 1 to column L row 2, column 1 row 1 to column, okay. Let's think about this. Yeah, this is going to be a fun question. Bro, it's sub day. I'm going to guess you meant Sunday. Yeah, it's Sunday, man, but we gotta do what we gotta do. But yeah, I'm gonna do this for an hour and then I'll probably go on a break and do some stuff around the house. But happy Sunday to everyone. Sunday fun day. But Sunday is a lot more fun when you get your hour of LeetCode in, because then you feel like not only I did something, and I also got to have fun. So do what you gotta do to make it happen. All right, let's see how we're gonna do this. So I want to print out everything. So yeah, K1, K2. I'll go as far. I guess I can always go, starting from K, I can go from 1 all the way down. This is K1 to L2. So is it determined by the last one how far I want to go? Does the last one always, like, does the last one always determine how far down I want to go? If I had, like, is it possible to have K1, can we have like K5? No, I guess we can have K5 to K3, or like K5 to L3. So I can exhaust all my options on the first column and keep going that way, right? You can start at K, yeah, if it was K5 L4, right? We can do, oh yeah, but like what determines, would this one ever be, oh wait, one is less, S consists of uppercase English letters in a string. Okay, so R1 is less than R2. Okay, so it will always be, so it will be something like this. So you're essentially bounded by this last one here. So if my upper bound is 4, and yeah, we exhaust everything from 2 to 4. Do K2, K3, K4, and now we start from 1. L1, L2, because I'm guessing it's always going to be like a 1, right? Yeah, K1, K2, K. It'd be nice if we can give this like, what if I just had a function that printed numbers in some range? Let's see, like function print column. And what if this took a column name start equals 1, and then end. Let's do end and start equals 1. So could we do something like const column equals this for let, maybe we don't need, we can just do this, start less than or equal to end, start plus plus. We can say column dot push, and then we create our string here, which will be the column and start. I think we can do something like this. Return column. So I would, like if I did, so here, if I did print column K, I gave it an end of 4 and a start of 2. What will this look like? Or const column equals print column console.log column. Oh, it didn't like that. Column, okay. Column, column data, I guess. Not my favorite thing, but K2, K3, K4. Okay. So I think what I can do now is for my cells, I don't really want to like split this 0, 1, 2, the next one, but I mean, we really could to make it a little bit easier. We can say like const cells for const, let's see, this is going to be interesting. For const column of s dot split at here, let's see what we can do here. All right, so what am I doing here? I'm getting all my cells, and then for const column of s dot split, I'm splitting on this. So now each one of these columns will represent K1 and L2. But now I am bounded, I'm bounded by that last one. And am I always going to start at, this was K2, I just start there. Oh, or maybe the start, let's see. I'll print one column and then I'll print the next column, start, end. Maybe my end is just always this. Maybe my end, right? My end can just be, let's see. Okay, let's forget end here. And then start less than or equal to, what if I just take, like, what if we do const end equals s? Let's do like parse int of s at s dot length minus 1. I'll pass in a radix. And then my start, will it always be, should it always be 1? Maybe it will only start for the first one here. I guess I can just run this thing twice. I don't really even need to. Yeah, I think I'm probably overcomplicating this piece. I can have column 1 equals, instead of print column, let's call this like generate column. Column 1 is generate column, where the column is s at 0. And let's say start, zoom out, bro. Yeah, hey, Dr. Lithium. Like, yeah, I know. The thing is, like, right now I'm streaming. It's mostly like for desktop viewers because I upload these to YouTube after, and I don't have my settings so that it renders out like nicely on mobile. So if you're watching it on mobile, then yeah, you're probably gonna get like some cropped out view. So I don't want to mess with it like live because it's like one of my first times using OBS. So what I'll do instead is I've taken a note already of it. So once this is done, I'll just do some experimentation on my own so that way I can get nice rendering for people watching on mobile, and then also for people that watch on YouTube, they'll get, the expected quality they want to. So apologies for that. I know it's kind of like squished, but we'll make do with it for this one time, and then hopefully the next stream will be better. Again, like I'm definitely gonna upload this to my YouTube channel afterwards. So if you want to watch this and follow along with me, just check out like in an hour or something, and I'll post it here on my YouTube, and then you can do the same thing there with the nice resolution, and you can follow along. So let's see, generate column from here. I want to start at whatever S1 is, right? And maybe I don't even need S2 const start equals parse int of start 10. I'll remove this here and I'll pass in s at 1. And then const column 2 is going to start from generate column s at 2. Start is 1. So will this work? Let's see. So column 1, generate column starting at A. Oh, but I'm completely missing all the intermediary ones here. That's where I went complete. Yeah, I completely missed on all these other ones. I just like assumed it's just always K and L. So that's not good. We need to also figure out all the different ones. But I sort of like this way that I'm going with it here, like just given a column. Yeah, just given a column. Let's just see how it works for this one here. Const column 1, const column 2. If I just do, yeah, let's just do that first one there. I want to get both of these. Column 1, column 2. Will that work? So from K starting at 1, so this will be a 1 and the end will be whatever it's bounded by. So it'd be 1 and 2. Then generate column 2 will start at L. We'll start at 1 and I'll go, so it should work for this one, const start. Oh, because I'm incrementing start, so let's not. Or maybe start index. Start index less than start index. Let's see what this gives us. K1, K2, and then we had some other weird looking thing. Is that because I'm not? Oh, 3. K1, K2, L1, L2. Now we need to also fill in all of the, we want to fill in all the letters in between these. So I guess we're going to need an alphabet. It's a little bit annoying. But I guess that's probably the best way to go through it. I think there's like alphabet generator JavaScript or something. No, not random. Online. There's like this cool website this guy made. Generate random out. No. Is it this one? Generate random strings? No. Alphabet generator. Generate the alphabet. Oh yeah, this was the one. This one's like pretty great. I like this one a lot. Although, can we get English alphabet, lowercase letters, separate? Cool. Nice. Oh, and can we also get, I still need to get, I still would want to get all the different, I still want them to be strings. But let's see if we can use this. Oh, or you know what? I'm gonna do it like this. I can't, I'm gonna open up VS Code on a different window here because it's gonna make this a lot easier. And I know you guys can't see this, so just bear with me for a second here. Okay, so I'm selecting all of these. Okay, last one. Okay, this should be better now. Okay, now we have what we want. So let's see how we can use this. And it's not, oh my God, it's not uppercase. That's awesome. It is not uppercase. Uppercase letters. Reverse the up. Separate symbols with this. Oh, it'd be nice if we can, this will get us kind of close. Oh man, so close. I'm gonna open Visual Studio again. I know you guys can't see. Again, just bear with me. Okay, we have that. This. Okay, this should work now. Let's go back to OBS. Okay, now we have our alphabet. So what do we need to do? Now instead of like, we need to find our range, then generate the column for each one of those. Column 1, column 2 in range, and we can append each one of these to our result. So let's see, columns, this, 4. Now we're going to need to find the first, the range that we're going through. So const index 1. Man, this is like, it's going to be a little bit annoying here because capital A in ASCII is what, 65, right? So I can do S at 0 is A, car code at 0 minus 65. I know this looks probably like mumbo jumbo, but S of 0 is going to translate to like the first character, right? And we say the car code at 0, which is this 0th index, is 65. We do minus 65, and that gives me the index of where I want to like go in this array to be able to get each one of my different characters. And then index 2 will be the same thing at 3, 0, 1, 2, 3, right? And now I feel like, can we do index 1 less than or equal to index 2? Index 1 plus plus. Let's make both of these let's make both let's. That's funny. So let's kind of like go through all this now because I want to generate a column. Const generated column equals generate column. Now what are we going to need? We want to pass in alphabet at index 1. And I guess the start the start for each one of these should always just be what we're S1 to S2. It's always going to be lower. It's almost like all the other ones will always need to start at 1, but the first one might. Oh, no, wait. It said that it was always going to be less, right? So what if I'm just going to make the start like 1 for now and just say, I know that's not going to be right, but I want to see what this does for me. So let's do let columns equals columns and generated column. Console.log columns. Okay, K1, K2, L1, L2. And if I do all of them, A1, B1, C1, D1, E1, F1. Wait, does it want me to do return columns dot join? Whoa. Oh, it doesn't want it. Yeah, it doesn't want it to be. Hello, lame fish. I have a feeling. Well, let's see. Yeah. Okay, so what I'm doing here, this is crazy that now our acceptance rate here is going to be altered, but that's good. That means that we're growing. So like it's only going to be, let's see. I guess only the end will always be 9, but the start is only going to be, yeah. I think I know why. Like if it's the first one, that's like really what I want to do. And now I don't even have, I mean, I could do something a little bit gross. Yeah, only if it's like the first one that we're going through. It's gonna look nasty. But let's try something here. Nasty is 0. I'm gonna leave it like this. If nasty equals 0, then I'm gonna do, uh, let's do this. Let generated column is this. If nasty equals 0, then generated column will be S at 1. Else it should start at 1. I think that's going to be okay, right? Because only for the first one, and then here we'll increment nasty. Only for the first one, it should start at 7. And after that, oh, does it always want it to start? Wow. Okay, no, completely wrong there. So I did make it harder for myself. The start will always be the same. U1, S at 1, which is 7. So why didn't it work? Yeah, that should just be S1. Let's undo stuff. Nice. So do I not need to use nasty? S at 1, columns. Let's copy this one, throw it in there. Let's see how this looks like. 102, X9. Wow. This question was really fun. It's a little bit like, oh, can we do, oh, man, that time. Oh, okay, this one's 83, but like, I got 2 others that were less than ideal. Okay, I want to take some of these things out. There's things that I can do better here, right? Like I don't need a start index. parse int start. I'm calling this every single time. I can do this once. Start index is parse int of s at 1, 10. Const end index equals parse int of s dot length minus 1 at 10. This just needs a column. We can get rid of this. Let's make this let. Oh, but I also don't want to. Let's make that const for start index less than end. Maybe I'll just keep these at start. I'll keep this at end. Let start index equals start. Let end index equals end. Start index less than or equal to end. Start index plus plus. This is going to be the same thing. Just going to keep like, okay, 26.2. Column data index 1. Yeah, I guess we'll still need to have this as well. I'm mostly happy with this. Like, let's think about the type complexity and things here. So we're for each one of these, right? We're going through, I guess, the difference, like the range of characters that they give us, which I guess it could, in the worst case scenario, it'll just be bounded by uppercase letters, right? I think. Like if this is A and Z, we'll only ever have to traverse 26, like O of 26. And then for each one of those, let's see, 1 through 9, the worst case it can be is O through 9. So does that make it constant? That's weird. Like it'll always be bound by these numbers, right? O of 26 if it's like A through Z, and then for each one of those, if it's 1 through 9, like at worst it'll just be 9. So I wonder if that just makes it constant. It's weird. This is one of those like weird time complexity problems. Because like sometimes I think it's like constant perhaps, but then you get something weird like that. I guess space complexity, um, I guess is space complexity also constant because we're only ever creating column data that's as big as the ranges that we have, but these ranges are bounded here. No solution. Let's see what the discussion on this is. Probably something super simple that I just didn't think of. Two loops, of course. Oh wait, I clicked on the guy's profile. Two loops in C++, probably super nice code. Whatever that means. C less than 3, S at 0. For car, R equals S at 1, R less than, res.pushback, CR, return res. That's the thing, like, beautiful code, but it's kind of hard for me to read. Let's see, cells in range, 0 less than 3. For car, SH for int I, S1 minus 0. Okay, I plus plus. I feel like they're pretty much doing the same thing, right? I see they're doing this like minus 0, which that's probably getting the index. Maybe here they can do some things in C++ that we can't really like afford. Yeah, because I guess here they're just doing the loop based on the, yeah. I mean, I could maybe do the same instead of getting the indexes, maybe just do this instead. I'm happy with this solution, and I think this is a fantastic question. Like I really want to put this one over here. I'm also gonna like this one. This is a nice question. I would say it's definitely, even though it's rated like up top for acceptance, I would definitely say it's like one of the harder ones. Okay, so I just realized I've been going over this for an hour and 15 minutes. It's definitely my longest stream to date. So I'm going to stop here. I'm going to go ahead and work on this and upload it to YouTube. So again, just for anyone that's like catching on right now at the end and they are interested in pursuing like their own LeetCode journey, they want to get in the habit of doing a LeetCode journey and solving these questions with me. I'm going to try to be consistent with this and upload these. Like I'm going to do my stream here and then I'll upload it to my YouTube so they'll last forever and you can just start from like number one, then go to two. And the streams are like, I'm doing all the questions in order. So like you don't have to worry like, oh, let's say like tomorrow's stream, it's not like I'm going to start on page like 4. So if you want to follow along and do everything from the first question, like literally question, what was it? Like add the numbers, yeah, add to integer. If you want to follow along with me, starting all the way from here, just start at the LeetCode accountability stream 1, finish this, then go to 2, and then you can watch the one that I'm going to upload, which is this one now. So if you enjoyed this, I truly appreciate everyone that watched it. Thank you so much for all the followers and the watchers and the score. I think it was so much fun. I might even do one of these later today. I have a pretty easygoing day today, but definitely keep a lookout on my YouTube. I linked to it earlier in the chat. If not, I'll just leave it here on the screen so you guys can look it up. So Rafael Negron, that's me. And yeah, keep a lookout on my Reddit channel, and I'll keep making these streams. Thank you all so much again for tuning in, and happy coding. Later.